Alright, time for another DraftPhysics.com video presentation. So, somebody called Science Debunker, I think is his name. It comes out when he types a comment anyway. It says Sci Deb, but whatever. He left a comment and was a little bit snarky, accusing me of being some kind of one of those people who thinks they know everything or something. Some kind of bullshit, because he was going to explain the double slit to me. That was his offer. Well, anyway, he took away the comment, so I guess he figured out that maybe I do know what I'm talking about. Only been doing it for 10 years, analyzing double slit experiments. But anyway, so he does have a video up, as I suppose is part of his explanation. Now, I have seen this done in water. They shoot a laser beam through the double slit and then put allow the beams to be seen in water. And, it looks like something, but it really doesn't mean anything. So it's really not a great argument against wave theory. I'm glad he's making that argument, but it's really not a great argument. And I don't know this guy's agenda, so the whole thing is a little bit... This is the only video he has up, and it's, there's no talking, there's just this text on top of, and basically saying that, he's done a certain thing, and I can't even say this is his content, that he actually produced any of this. It says here, strands are seen colliding. There's no strands you can see in the actual image he's using, which is really kind of funny, and you don't see them until much later in this kind of image, where you can see that the fringes still have beams that are strong enough to be seen. Now, that doesn't mean that this does not annihilate wave theory, in the sense that all this is really saying is you're just moving the target closer, and obviously the fringe pattern exists. I can bring the target closer and closer and closer and and theoretically the pattern's still there, it just gets smaller and smaller, but it's still there. So you're really not saying anything, you're not proving anything. So let's see the best images. So I'm all for somebody saying it's not a wave, but this doesn't actually prove it's not a wave, because all you're really saying is I'm going to create dirt. The light's going to be bent by the dirt in the air. So all these beams that are in this image, those are all photons that don't get to the target. Okay, they've been stopped from getting to the target. And what you've just basically done is taken the target and moved little pieces of it into the atmosphere at different locations. And you're just saying, see, look, the pattern's still there. Yeah, well, wave theory has a counter argument for that. So as much as I don't want to defend anything wavy, of course, this isn't a good enough argument. So I guess I'll draw it just to make it clearer. Because, it seems like the right thing to do is to try to make it as clear as possible. Explain where possible. So that's what I'll do. So that's the kind of person I am. Anyway, I'll defend what I'm saying and such. That's camera's way off. Well, that'll have to do for now. Okay, so obviously, yes, whenever you see laser beams going someplace, you have to recognize that the photon, whatever its origin is, it's just that you're saying that I've put a target at this location, or a little piece of dirt at this location, or a little piece here, or a little piece here, and that light bends off, reflects, and comes into somebody's eye over here, and that's what they're seeing. So they're seeing photons that don't make it. They don't go any further. They hit the target here. And the pattern, okay, the on-off pattern, it's big over here, and it gets smaller here, and it gets even smaller here, and it gets even smaller here. So you would expect there to be pattern all the way back. And you could argue that because the wavelength of light is so small that, in 1 millimeter of distance, I don't know what it might be 1,000, it might be more than that, it might be 1,000,000, but I'm just saying, let's say 1,000. There's 1,000 wavelengths in that distance. So there's plenty of time for them to do their, silly Huygens thing with waves on top of waves on top of waves. There's plenty of time for them to do their interfering crap. So you haven't eliminated the interference by their description. Now, I'd obviously say the simple answer or solution to understanding what's happening is the facts that you can get from looking at this kind of experiment. You'll see that the beam going to the center is really substantial. So the little center part here is very bright, and this stuff is a lot less. It's 5%, 3% as bright as what goes to the middle. So you can understand that this is much less photons in this fringe pattern. The fringe pattern is being made by very few of the actual photons that go through the slit. And so that's partly a giveaway. And the other giveaway is in their own math. Because what are they using in their math as the distance? One of the critical distances. They're using this distance. They're using different distances. But one of the critical distances is the distance between the two surfaces. They're not measuring some Huygens thing, where, oh yeah, one wave turns into two waves, come out of the single slit, and they interfere with each other. Yeah, they're not doing those centers. That's not the distance in the math. The distance in the math is this surface and this surface. So they really are directly comparing vector from here and a vector from here. So I don't even know why there's even any doubt that what's causing the fringe pattern is photons that are originating from these point sources. The surfaces are the point sources. All the photons that don't go near the surface go straight through, and the only ones that make fringe photons are the ones going by the surface. And the key is when it goes by the surface, what it's really doing is getting broken. It's not a visible photon anymore. So you won't see this beam, and you won't see this beam, because it's not a whole photon, it's a broken photon. And it's only when it reaches this screen at this location, okay, and it's in phase, then it becomes a photon. But if I move the surface in a little bit, it'll turn on, it'll turn off, it'll turn on, it'll turn off. So for every distance I move this way, I'll change what this vertical line would produce, or what this vertical line will produce. It'll be on here, it'll be off here, it'll be on here, it'll be off here, it'll be on. It'll be doing the same thing in this pattern. So you're seeing that I'll keep changing this to on and off as I move this piece of the target. If I just took this piece of the target and I moved it closer and closer, you could see, well, I take this piece because there's stuff above it and below it. As I move it closer and closer, this would turn on, and then would turn off, and then would turn on, and then would turn off, and would turn on. Because I'm adding these two pieces, and I'm saying it has to be a whole wavelength of difference to be an on. Closer to whole wavelength and half wavelength. So if there's a half wavelength and they're out of phase, then I got nothing. If they're in phase, I got something. But you're just making a photon out of two beams you'll never be able to see, because these aren't whole pieces of photon that are actually doing the traveling. But there's no interference. There's no interaction between the photons until they hit the surface. And as I explained, you can understand that to be the truth based on the radar or the radio experiment, where you have the two antennas opposed to each other and you have the signal sent. And so the two signals will never interfere with each other, and you just move the antenna in between those two signals and you create the same on-off pattern, indicating that it really has nothing to do with interference. It has everything to do with phase and out of phase, in phase, out of phase, in phase, out of phase. There is no interference. They're not interfering with each other. You're either combining the pieces and making a photon that's in phase, or you're combining the pieces and they're out of phase, and therefore it's not a visible photon. So that's a simple response to that argument. So not a very effective video in proving, okay, it's a particle. But, I'm glad he's making a video. I mean, it's something. I guess it's somebody arguing against jumping to the Young double slit conclusion. Now he actually says something in here that's, kind of unfortunate. He points out how you could use a needle and create the same pattern. Well, it won't be the double slit pattern. It won't be the pattern you showed in your video. It'll be a different pattern. The single slit pattern, the two source pattern, is different than the four source pattern. So, you're making a few mistakes in your video that if you want it to be more credible, you shouldn't make those mistakes. Okay, that's a simple thing to say. All right, so there's nothing to play. He doesn't talk. He just has text, and it's not that interesting. Okay, so we'll move on to the Degrassi Tyson crapola. Same subject, just really, it's just an example of just how sloppy and imprecise their science is. All right, so back. So this is a Neil deGrasse, one of his whatever it is called StarTalk podcast things, where he does this whatever, mixing some sort of a comic thing, okay, with physics. It's just so bad. But anyway, so I'll play the video. There's just nothing, it's just yuck.
It's going to read the question, but then you got to break down everything that's a part of it in order for everybody to know what I'm talking about.
Well, this is your day and Gary's day, so I'm at your service.
Okay, cool.
Okay.
Yeah, Gary was involved. Anyway, this isn't his question, and the whole thing is just, so bad.
All right. How can a single electron passing through biprisms or slits?
So he says biprisms are slits. You really can't do it with slits, right? If you really think about what an electron is, it's charge. You can't make your slits neutral enough for an electron. So there's no way you could really aim electrons at anything slitty without screwing with them dramatically, because they're charged. They can't see the surfaces as anything other than either positive or negative.
Interfere with itself.
Right. So, this argument that somehow it goes through both slits is just absolute nonsense. And that experiment really hasn't been done, and it's all just a fake. They can't make single electrons, and they can't make single photons. And so all of that crap that somehow the pattern still happens when single objects are in the environment is just that crap.
Nobody knows.
Oh man, come on!
Next question. Yeah, no. These are the mysteries of quantum physics. Like I said, and Gary, finish my sentence. The universe is under no obligation
to make sense or care about your gender.
Right. So it's just stupid. We have the intelligence. We can figure out Daffy Duck didn't do it. So if somebody comes up with some explanation that Daffy Duck did it, the Invisible Man did it, some magic did it, or some bullshit did it, we're capable of saying that's a cop-out. And that's all this is a cop-out. Their model doesn't work. And to just evade worrying about it, they just say, we'll just pretend whatever circumstance we need, we'll just invent whatever fake thing we need. So if we need a gremlin, we'll use a gremlin. If we need a pixie, because pixies are smaller, we'll use a pixie. So they're just contriving nonsense to answer questions instead of being grown-ups.
All right, so in that case,
the point is, particles can behave as waves, and
So then, behaving as a wave is different than being a wave, or element to be constructed as a wave. And we know that the photon, by your argument, is an elemental wave, not a particle wave. So again, it just falls apart as nonsense.
Right. Okay, so I get the duality of light and that it's a wave and a particle.
I don't know how you get it. How do you get that exactly? I can't get it. Yeah, I can't get half of the equation even by itself. The wave thing. What's creating the wave? I mean, what? How does it know it's supposed to go up, and now it's supposed to go down, and now it's supposed to go? How does it know all that shit?
Yes.
Okay. But, so first of all, maybe we should tell people what the double slit experiment is.
Okay. So here's the thing.
All right, so the double slit experiment isn't electrons, right? It started with Young and photons, so let's not pretend they do actual double slit experiments with electrons. Now, they did put a tiny, out of gold, with two little slits, and they did put it inside of an electron gun, and it didn't work, really. The pattern was shit. This is all just kind of bullshit. And the fact is that the experiment isn't done the same way. It's not the two slit experiment, or it's not the single slit experiment. It's not. And the patterns don't match. The double maxima is missing. All kinds of features are not consistent. So it's just bullshit.
You're looking at electrons coming through. You have this barrier.
Right.
And you put two slits.
All right, so this doesn't happen. So let's just understand this is not how they do it with electrons. They aim the electrons, okay? There's so many differences in the experiment. There's just no way of comparing it. And again, electrons are charged. You really have no hope of doing the same experiment with an object that's charged. Everywhere it goes in the universe, there's a charge differential. It can't possibly travel a straight line unless you've already decided, you've already figured out where the highest potential is in terms of the charge potential, and you happen to just be shooting it in that direction. You just happen to be shooting it in the direction the charge differential is the greatest. But otherwise, it's going to be bent. It cannot possibly travel a straight line.
Adjacent to one another. 6 inches, it doesn't matter. Just separate them. Do two slits. Then you have a screen on
6 inches? Again, for an electron, no, it can't. You can't have a 6 inches. What are you talking about, 6 inches?
the other side. And you fire electrons into this, and you know where the electrons are. You fire them in.
Well, let's understand. They do know where they are because they're aiming them. So that's the difference. Okay, they have to aim them because the fact is they'll go all kinds of silly directions if they don't force them. They have to force them to go. And in forcing them to go, they're automatically aiming them because they have to push them. And they're not like photons where they can just release them and they go in almost any direction. They can start with that. That's not how electrons work. The only way you can get them to move is that you have to create this electrical potential. And the electrical potential is going to have a strongest field, and they're always going to go where the strongest field is. So you can't really shoot random electrons.
And you'll get 2 points of intensity on the back screen.
So this is the big lie. That doesn't happen because the two slits are so close to each other that on the screen it's still just a half millimeter, or in the case of this electron experiment, you're talking about nanometers of difference, a few nanometers of difference. They travel a straight line. They go straight, the two lumps. The two lumps would be a nanometer apart from each other at the screen. The light isn't there's no separation if there's no fringes. The fringes are being created by the fact that you're deflecting the light in a new direction. If you don't deflect the light in a new direction, that is, you're not creating a fringe pattern, then the light will be nanometers of difference. The two dots will be right on top of each other. It'll only be how do I even do a nanometer of difference? You're not going to be able to see a nanometer of difference between these two lines. They're going to hit the same spot. It's going to look like they're identically right on top of each other. So even this part, is bullshit. Because even if I did it with light, the two slits, if they were going to create two humps, the two humps would end up being, even at 10 feet, they'd end up being right on top of each other on the target. I wouldn't see two different headlights. Because the two source headlights are so close together.
One in front of one slit, one in front of the other slit.
So big, fake, phony fraud. It doesn't happen. There's no diffraction. There's no deflection of the light unless you're creating a fringe pattern.
And there's to be some fade off to the left and right.
So just nonsense. So he's never done the experiment, never looked at it, never seen this. It's just a fable. It's just a story they tell.
That because some will get bent a little. Okay, that's what happens if they are electrons. Now you don't look at it.
So what does he it's hilarious. That's what happens when there's electrons. So he forgot the part where he's supposed to say, well, you have detectors and you detect which slit they went through. And now he's saying when you don't look at it. What do you mean when I don't look at it? That's just hilarious, right? So he's saying when you don't see what hits the target, that somehow something else will hit the target. All of a sudden there'll be a fringe pattern if I don't look. Whatever that even means.
And you do the same experiment. On the back wall, you don't see two peaks. You see what
you're not looking at it, but you see it. Okay, yeah, okay. Sure you do.
What's called an interference pattern of the variation.
It's called an on-off pattern. The simplest pattern you can create in the universe. On, off, on, off, on, off, on. The simplest pattern you can possibly create. And, that's what it is. Interference, says you. Where's your evidence?
Of light and dark peaks that completely spreads across the projection surface.
So it spreads because of the fact that whatever the cause of the deflection has a whole range that it can deflect in. And the fact is it's not unlimited. The number of photons that are deflected at, say, 80 degrees is much smaller than the number deflected at 10 degrees. So we know that whatever's happening, it happens on a gradient, and it's more likely to happen a little bit than it is to happen a lot of bit. So 80 degrees is a lot less likely than 10 degrees. Meaning it's probably something that's additive. That is, the photon has to hit more than one thing to be bent 80 degrees. And if it just hits one, it can, it's bent a little bit. If it hits two, it's bent more. If it hits three, it can be bent more. But it's unlikely to be bent. It's unlikely to have enough interactions to be bent at 80 or 90 degrees.
Because when you didn't look at it, the electron behaved as a wave. And when you did...
So, absolute nonsense. When you didn't look at it, it behaved as a wave. No, that's when it behaved as a particle. Well, no, he's saying it behaves as a wave in the sense of the fringe pattern is visible when you don't look, and then when you look, it's two dots. So it's just absolute nonsense. It's the same target. It's a target. It has nothing to do with looking at anything. It's just absolutely, just complete nonsense to say there's any such thing as the we looked at it or we didn't look at it experiment. That's just baby talk. Isn't real.
Look at it, it behaved as an electron.
So there's no detector experiment. So usually they talk about, well, he's going to say that. We shine light on the electron, it disturbs the electrons. Well, if it disturbs them, if your detector is pushing the electrons, then the dot should be pushed in one direction. Shouldn't be the same two dots. You should be deflecting them all the time then. So you see the dots in two different locations, indicating your photons move them. So there's obviously, it's not a real experiment because he doesn't describe it as it would really happen. If the photons you're using to detect the electrons are disturbing the electron, then you would see that disturbance.
And so when waves can interfere. So a wave is just what you think it is. It's ups and downs. If you have two waves that are intersecting with each other.
Right, so there's absolutely no need for that. That's what the radar experiment, when you have the two sources on opposite sides, that's what it's demonstrating, is there's no need for any intersection. There's no need for crossed paths. There's no need for the energy to affect itself. And again, it's so anti every other piece of evidence we have. Every experiment indicates that forces do not interact with forces. You can't bend light with magnetism, for example. Well, if it's supposed to be electromagnetic, how is it possible that you can't bend it with a magnet? Of course, you should be able to if it's happening in an electromagnetic field, and you introduce a magnet to that field. you're changing the electromagnetic field, and it should change how the photon perturbates. You know,
There'll be points where the crests match up. You get an extra.
points where it's in phase and points where it's out of phase, and that's what's simple argument. You break the photons, and you have a 50-50 chance that when they hit the surface, they'll be in phase or out of phase. Perfectly explaining why there's an on-off pattern. Half the photons arrive out of phase, the pieces. Half the pieces arrive in phase. Not complicated.
High peak. Points where the troughs match up, get an extra low peak, and these just continue. And you get all combinations of the two.
So, and whatever combinations you get are strictly controlled by the distances between the surfaces. So the biggest distance, the outside of the two-slit experiment, the two outside surfaces have a very large distance, meaning lots of wavelengths, meaning lots of places where there's a full wavelength of difference. So they're making the little bars. And the envelope pattern, the secondary pattern placed on top of those little bars, is being controlled by the smallest distance. And it's so completely explainable as a phenomenon where the surfaces are covered with electrons, the photons are hitting the electrons are moving in and out of the surface, so you're deflecting the photon essentially either that way when the electron's moving out, or that way when the electron's moving in. And it's just clear that the surfaces are just creating the fringe pattern. They're just shooting pieces. So you have two guns in the single slit or the single impediment experiment. You have two sources, two guns. And it's basically saying we're shooting pieces of photon from these two locations. And you're just saying, where are they in phase, where are they out of phase? That's it. And in the double slit, you have four sources. You have two guns on the inside, you have two guns on the outside. And you're just doing the same thing. And you're saying, well, where are they in phase? Where are all four guns in phase? Where are all four guns out of phase? Simple explanation, done, finished, no wave-particle duality.
And what that looks like, and what we call it in physics, is an interference pattern. And that's evidence that for that very...
So it's an on-off pattern. It's a phase, out-of-phase pattern. It's lots of things, but there's no evidence at all that any photon interacted with another photon. Zero evidence that any of that actually happened.
Into the experiment, the electrons were behaving as waves.
So the electrons and the photons, not the same experiment, completely different objects. Just really silly to make the comparison. Completely different pattern created through a completely different mechanical mechanism.
Now, what does looking at it have to do with it? Because if you're looking at it, you got to shine light on it.
Right.
So he's not really talking about looking at it as seeing the pattern now. He's talking about looking at it in terms of which slit did it go through. And so he's so inarticulate. This is such a pitifully bad explanation. So he's saying if you attempt to detect, okay, then you can't see the pattern because your attempt to detect has de-entangled the photon from being a wave and now turned it into a particle. I mean, it's just too silly.
If you shine light on it, because otherwise it's an experiment in the dark. You have no idea what's happening at all. The moment you shine light on it, the light...
So again, it's kind of funny that he says it that way, right? Because the previous video, the whole point of it was to make the beams of light visible. To do it in the dark and allow the photons themselves to show you what they're doing. But obviously that's deceptive because the photons you see are going to be the photons that didn't get to the target.
Interferes with the electrons being waves, and they become particles at that point.
So gravity doesn't do that, though. So you can de-entangle, whatever that is, de-entangle an electron, okay? You can knock it out of its superposition with a photon, but you can't do it with a force like gravity. So gravity doesn't de-entangle, okay, but photons do. I mean, it's just a silly standard.
And so it's called the observer effect. And New Age
you know, so what other radiation can I shoot at it to de-entangle it? Will the particles of radioactive decay de-entangle? I mean, gamma rays, do they de-entangle?
Circles want to believe that it's your consciousness that's affecting it.
Yeah, well, nothing's affecting it, and you've poorly described a simple experiment that's where the deductions of the right answer are already obvious. Again, their own math counts the distance between the surfaces. Their own math is telling them that the distance between the surfaces is the distance between 2 point sources, and you're just doing the simple vector math. You're just saying, how long are these lines, these rays, coming from those 2 point sources? Has nothing to do with a wave, and has nothing to do with a wave intersecting. It has to do with direct vector length lines from location to location. They draw it as all straight lines. There's no waves in the drawing of the math. The math is all straight line vectors.
And that's one of the biggest misconceptions that continues.
That's ridiculous.
Who was it first discovered?
So this is just too silly, this big misconception when they have so misdiagnosed such a simple experiment. All right, so this is where the whole thing was a setup, because this guy asked the question. It seems kind of simple, like, the obvious answer was young is what he's supposed to say here, and he doesn't say it, which is funny.
Covered this with waves back in the day. Way back.
Who discovered this back in the day?
Well, we knew about the wave interference, okay, because you were always shining light on your electrons. But
So too silly, right? The electron experiment came much later. This fringe pattern thing was actually already understood well before Young, when they tried to do single photon experiments. So Newton did the single impediment and he did the single slit. Yeah, we have no record that he did a double slit, but he did do the two ways you can, the two surface modes, outside surfaces versus inside surfaces. So he did do those two modes. So this was always well established. And, they had already attempted, prior to Young, I believe, the first experiment, to do it with a very slow, a very weak photon emitter. So they took a candle, a gas flame, put filters in the way, and then, tried to reduce the amount of light coming through. But obviously, as I've pointed out, all those filters did was create a bunch of slits, a bunch of surfaces that the light was diffracted on, and the photons were broken. So there's no expectation that you aren't sending a ton of broken photons into the experiment, and broken photons work just as good as real photons, because the slits just are going to say, all I need is something to put back in phase, and I'll put them back in phase.
Electrons had to be discovered, right? The electrons were not known in antiquity. They had to be discovered, and then you got to know how to manipulate them, and then you do these experiments. This is all. We are in the centennial decade of the birth of quantum physics.
Yeah, whatever. The birth of nonsense explanations, wooey mush about reality. And yeah, it goes all the way back to 1801 for Young and his poorly drawn, frankly, diagrams of the fringe pattern. He didn't use monochromatic light, and frankly, he was analyzing a single slit pattern, not a double slit pattern. The patterns he got were single slit patterns, not double slit patterns. So the whole thing is just it's so layered in distortions of the reality. They're not telling you the actual story, just like they don't tell you that Ennington stated in his journal that he wouldn't stake his life on these results. And he only got 10% of the data quality he was hoping for. So, I mean, it's all just bullshit physics. It's all just stories based on so many half-truths and blatant disinformation, fake stories, fake history, fake experiments never done. Anyway, alright, so that's probably enough. I've been over the details in other videos, so I don't think there's, I don't think I'll bother doing it in this video. I'll probably do another revision video explaining all of the details that can be understood about the double slit and how every single one of the solid facts points to the fact that there's absolutely no need for any wave function at all in explaining what's happening to the photons, the quanta, the light quanta, as Einstein would say. Alright. So, enough of the video, till the next time, and such, and so forth. Yeah, I think that's it. He changes the subject to some other bullshit.
The 1920s was a seminal set of years where quantum physics was discovered. Hubble discovered that we're not the only galaxy in the universe, and he discovered that the universe was expanding.
So he didn't do that, so that's not Hubble's opinion. So that's sort of an irony that, you know, they're placing Hubble's name on the expansion theory when Hubble was more of a tired light guy. So even that's part of the bullshit. Let's just pretend, let's just lie about what people thought, you know, and pretend that, you know, Schrodinger was a big fan of quantum mechanics when, of course, he wasn't. So just such bullshit. Anyway, till the next time and such, so forth and whatnot.